Welcome to this video. We're going to learn how to do heat exchange problems in IB Physics. This is topic 3, IB Physics SL. Okay, let's say we have some water at an initial Celsius temperature of 45 degrees, and the mass of this water is 45 degrees Celsius. The mass is 2.0 kilograms. And the specific heat, by the way, specific heat capacity of water is 4200 joules per kilogram, or kilogram to the negative 1, Kelvin to the negative 1. Let's try a K once more, Kelvin to the negative 1. And we take a block, which we've heated up, and we place the block into our water. The block has a specific heat of 1500 joules, kilogram to the negative 1, Kelvin to the negative 1. And the initial temperature of this hot block is, let's say, it's at 79 degrees Celsius. And the mass of our block here is 4.5 kilograms. We let these two things sit. They are insulated from the surroundings. And insulated means they only exchange heat with each other. The heat exchange, Q exchange, is only with each other. Okay? And after some time of exchanging heat with each other, the block loses some heat, the water gains some heat, they reach the same temperature. They have the same final temperature, which I'll just call theta F. Our task is to find that final temperature. Alright, here's how you solve. Let's ask this question first. If these things are exchanging energy only with each other, does that mean that they have the same Q? Same Q? Do they exchange the same amount of heat? Imagine that the Q value is 10 for the water. It's not 10. I'm making up that value, but imagine it's 10. The water is going to be gaining energy as it rises in temperature. Where does the energy come from? The water is gaining energy that is released from the block. So if the water gains 10, then that means the block releases 10. But wait a second, I just said the block releases 10. So we see now that they do kind of have the same Q, except one is positive, the other is negative. Positive 10, we see, is it equal to negative 10? No, of course not. To make this equation true, we need to add in another negative right here. And now, instead of positive 10, I can say the heat, the heat transferred to the water is equal to negative the heat that is given off from the block. Okay. And that equation right there is our starting point. That equation is our starting point for this problem. Okay. We know how to calculate the heat that is gained by the water. It's the water's mass times its specific heat times delta T, which is theta final minus theta initial. And for the block, we have the mass of the block times specific heat of the block times delta T, which is, again, final minus initial. Now remember, everything on the right side is for the block, everything on the left side is for water. So I should probably put subscripts here. Right? The water's initial temperature, and this is block, and the block's initial temperature. They have the same final temperature, so I don't distinguish. Look at this. We have an equation. We know the mass of the water. It's 2. We know the specific heat of water. It's this value, 4200. We don't know theta final, that's our unknown, but we know the initial temperature. The mass of the block, we know. Specific heat of the block, we know. There it is, bam. And theta initial for the block, we know that as well. So we have one unknown, theta final, and one equation. We can solve this. Now, I'm not going to solve this here right now, but you will have some problems for homework where you get to practice solving these equations, and you will see the solution, which gives you the correct answers.